Greetings everyone, my name is Bhavay Chopra. The title of my project is Spotify Data Analysis. So this is the outline of the presentation today. First, I'll be introducing the project. I'll talk about the objectives, the data, the models that I've used, the motivation for the project, the results, and the conclusion, and so on. So this project is all about Spotify data and music in general. And the project I'm currently undertaking focuses on the application of machine learning techniques to improve the overall experience of music platforms such as Spotify. Given the increasing prominence of music streaming platforms such as Spotify, accurate genre detection has become essential for personalized recommendations and user experience optimization. And the objective initially was to classify genres only, but it expanded significantly based on the data that we collected. And all the objectives will be discussed in detail later on during the presentation. Utilizing the extensive music library and detailed audio features offered by Spotify's API, this project aims to develop robust classification models capable of reliably categorizing songs into diverse genres, including but not limited to pop, rock, country, EDM, rap, and classical. The initial phase involves comprehensive data collection and pre-processing to ensure data integrity and suitability for analysis. Subsequently, exploratory data analysis techniques will be employed to investigate the relationships, trends, and potential outliers within the audio features across various genres. These insights will inform the selection of relevant features and guide the model development process. The core of the project lies in the construction and refinement of classification models. Algorithms such as random forest, naive Bayes, k-nearest neighbors will be explored, with a focus on optimizing performance metrics like accuracy, precision, and recall through iterative experimentation and hyperparameter tuning. Further investigation will dive into the characteristics that distinguish each genre, such as tempo, energy, instrumentation. Additionally, the project will address the complexities associated with classifying songs that exhibit characteristics of multiple genres. In conclusion, the project seeks to contribute to the advancement of music genre classification, highlighting the potential of machine learning to revolutionize music discovery and recommendation systems. And the insights gleaned from this endeavor may have far-reaching implications for the music industry and the overall listening experience. So these are the objectives of this project. The first and foremost is music genre classification. Second is understanding music consumption patterns and user preferences. Third is to predict user song preferences, whether the user likes a song or not, or will like a song or not that they may listen to. And the last is classifying songs into their respective playlists based on musical features. So this is the data that I'm using for my project. First is the GTZan dataset, which is a publicly available open source dataset, which consists of audio files from 10 different genres. And apart from that, I've also taken multiple datasets from the Spotify API. I've extracted Spotify audio features. I've taken Spotify 2023 hit songs, and the last FM dataset as well has been taken from the Spotify API. So this is what the data looks like. As you can see, this is the GTZan dataset, and on the left you can see there are 10 genres such as blues, classical, country, disco, hip hop, and each of these have 100 audio files. And through a library called Librosa in Python, these have been pre-processed into the data frame that is shown below. As you can see, there are features such as there are chroma features, there are spectral features, there are zero crossing features, and it's a very vast list of audio features, which are completely different from the Spotify audio features that are extracted from the API, as you will see in the next slide. So this is what has been extracted from the Spotify API. As you can see, the last FM data, this was used for association rule mining. It's a record data set, which has artist names, it has the country, it has the gender, it has the user ID. And this particular data set, whether a user dislikes a song or not, as you can see the target variable, which describes whether the user likes that song or not. And these are the audio features, as you can see, such as acousticness, danceability, duration, energy, instrumentalness, liveness, loudness. So let's dive into the project itself. First, we will talk about association rule mining. As you can see over here, I've implemented association rule mining on my dataset. And this is the dataset that I've used, the last FM dataset, which is a record dataset. Here is some of the exploratory data analysis. Now let's talk about the association rules that we've found. So popular artists such as Bob Dylan, Sigur Rós, and the Rolling Stones exhibit high support, indicating their frequent inclusion in users' playlists. This suggests a strong preference for these artists among the last FM user database. And genre preferences, as we can see, association rules like Judas Priest going to Iron Maiden reveal a tendency for users to group artists with similar genres, suggesting the presence of distinct genre preferences among listeners. And confidence analysis identifies strong associations between artists such as Oasis, The Killers, and Coldplay. And this indicates a high likelihood of users including Coldplay in playlists that already contain Oasis and The Killers, suggesting shared stylistic preferences or listener demographics. Some unexpected associations that we saw, like the Lyft analysis, uncovers interesting relationships with unexpectedly high strengths, such as the Pussycat Dolls associated with Rihanna. These associations suggested potential cross-genre appeal or previously unknown correlations in listener preferences. And the diverse music landscapes, such as the presence of rules like Pink Floyd, The Doors, and Led Zeppelin, highlights the diverse range of musical interests within the dataset, encompassing various genres and eras. Now we will move on to the decision tree model. As you can see, this is the data that has been used for the decision tree model. The objective, this part of the project aims to classify a song based on whether a user may like it or not like it. And the Spotify API data was collected for a user with liked and disliked songs, and the features of these songs are extracted into a CSV file. And the analysis used decision tree classifiers to predict user song preferences from Spotify data. 3 different models were compared. First was a default decision tree. Second was the grid search CV tuned, and the last one was the randomized search CV tuned. And let's quickly go to the results of this. So the default model gave us an accuracy of 73.27%. The grid search CV model with a slight improvement gave us an accuracy of 73.47%. And the randomized search CV, which had the best performance out of all of them, she gave us an accuracy of 73.86%. So the decision tree models revealed the importance of different audio features in predicting song preferences. Features like danceability, energy, and loudness were found to be influential in the decision-making process. Hyperparameter tuning improved model performance, highlighting the importance of careful model selection and tuning. Overall, the analysis proved valuable to insights into predicting user preferences for music based on audio features and highlighted avenues for further research and model development in music recommendation systems. Our next model that we used was a knife-based model. Again, the objective here was different. So when you're listening to a new song on Spotify and you like the song and you're looking to add it to one of your playlists, the playlists shown are in no order of any particular meaning. This part of the project aims to classify songs based on audio features into the best choice playlist. Make no mistake, this won't add it to the playlist directly. Rather, it ranks the playlists where a song would ideally belong using knife-based classifier. And the playlists are shown in order of their ranks and based on the probabilities obtained from the knife-based classifier. So for this part of the project, 4 particular playlists were considered. These are the classical essentials: Get Turned, Rock Save the Queen, and Coffee Table Jazz. So this is what the data looks like. So F1 stands for playlist 1, and these are the features that have been obtained from the first playlist. So this is some of the exploratory data analysis that was done for this part of the project. And as you can see, this is a confusion matrix over here. So the knife-based classifier performance varied across different playlists. Highest accuracies were achieved for the Rock Save the Queen playlist and Get Turned playlists, while classical essentials had the lowest accuracy. Knife-based actually outperformed K nearest neighbors algorithm classifier in overall accuracy across most playlists. Classical essentials playlist actually posed a greater challenge due to the subtle audio feature difference in it. And some conclusions that we can take away from this are certain genres exhibit more distinctive audio features, allowing for accurate classification. And the knife-based performed better than KNN, suggesting the effectiveness of probabilistic assumptions for this task. Feature importance varies across genres, highlighting the need for careful feature selection and engineering. Potential improvements could include exploring advanced knife-based variants and ensemble methods to improve the classification accuracy. Overall, the analysis demonstrated the effectiveness of knife-based classifiers in music genre classification, providing insights into genre characteristics and classification performance across diverse playlists. Next was our clustering analysis part. As you can see, this is the data that has been used for this part of the project, and it consists of the same audio features as the previous data set. So this analysis was regarding clustering techniques applied to Spotify audio features data set and utilizing both k-means clustering in Python and hierarchical clustering in R. The aim was to cluster similar songs together using an unlabeled data set consisting of audio features. The k-means clustering in Python revealed the data set forming 2 distinct clusters. As you can see from the silhouette method, it shows 2 clusters would have been ideal for this. And the hierarchical clustering in R based on cosine similarity also identified 2 clusters supported by a dendrogram and the elbow method, as you can see over here. This is the dendrogram which identifies that there should be 2 clusters, and this is the elbow method for the same. And the conclusions that we can take away from this are consistent identification of 2 clusters across both k-means and hierarchical clustering methods suggests a significant dichotomy in Spotify audio features. Features like loudness, acousticness, and energy played a crucial role in distinguishing these clusters. Let's move on to the next part of analysis, which was the SVM method, the support vector machines. As you can see, this was the data that was used over here. The analysis focused on utilizing SVMs with various kernels to predict whether a song would reach the top 100 charts on Spotify. 3 kernels were explored for this: the linear kernel, radial basis function, and the polynomial kernel. Let's talk more about the objective first. So the objective was to predict whether a song would be on the top 100 charts of Spotify, which means whether the song would be a hit or not. And it is obvious that just the musical features of the song will not be the only features that matter. So there are multiple features that we have taken over here, such as the age of the song, how many months it's been on Spotify, and along with the audio features. Let's talk about the results. So these were the results for the linear kernel, the radial basis function kernel, and the polynomial kernel. And this was the graph that was found. This was the graph of the area under curve of the ROC. As you can see, the area under the curve for the linear was 0.63. For RBF, it was 0.55. For polynomial, it was 0.53. And the objective is to maximize the area under the curve. So clearly, we can see that the linear kernel has performed the best out of our 3 SVMs. So linear kernel achieved the highest cross-validation score, but struggled on the test set. The RBF kernel exhibited similar challenges in generalizing to an unseen data set. And the polynomial kernel with degree 2 showed promising results in cross-validation, but faced difficulties in the test set accuracy. In the conclusions drawn from the analysis, it became apparent that the audio features and traditional machine learning methods may have limitations in capturing the multifaceted nature of music popularity. This complexity includes factors such as artist reputation, marketing efforts, cultural trends, and subjective listener preferences, which are not easily quantifiable through audio analysis alone. The study suggests potential avenues for improvement, including the adoption of more advanced techniques such as ensemble methods or deep learning models, and enriching the dataset with textual and social media trends. Additionally, incorporating domain knowledge from music experts and considering the broader context of the music industry could enhance prediction models. The limitations of audio features in traditional machine learning methods were evident, as they may not fully capture the complexities of music popularity. Now let's talk about genre classification. So this objective was carried out on two different sets of data, the Spotify API data as well as the GTZan data. Both data sets made use of different audio features for the classification, hence came about the interest to use different data sets. Now I'll show you the code for these. As you can see, this is the code for the music genre classification using the Spotify API. And the data was gathered using Spotify API, and these were the features that were extracted from the API. Let me show you a sample of the data set. So this is what the data set looks like. As you can see, these are all the music features that were extracted, and there's a label over here, that's the genre. And for this particular task, we've used 5 genres only. And these genres are EDM, classical, country, pop, rap, and rock. So this is some of the exploratory data analysis. Now let me show you the results for this. As you can see, multiple models were used over here, and the results for the models are as shown over here. We have used k-nearest neighbors, logistic regression, linear SVM, decision tree, random forest neural networks, naive Bayes, as well as some random guessing baseline models. And from this, it's clear that the random forest model has performed the best out of all of them, with a 76% accuracy. So this brought about the need to carry out some more hyperparameter tuning. And we did this using randomized search CV as well as grid search CV. And the final fine-tuned model gave us an improve of 1.1% in the final validation set accuracy. And this is the result of it. So the final accuracy we achieved on the testing set was 77.09%. Now let's talk about the GTZan dataset as well. The GTZan dataset over here, as you can see, in the slides, it was shown that the audio files were converted to audio features, and these are the audio features that the GTZan dataset consists of, which are far more vast compared to the Spotify API data. These are traditional audio features, and rather than just acousticness and speechiness. And this is the list of the features over here, and this is some of the exploratory data analysis. Now let's dive straight into the results of this. For this particular task, I used a neural network, and the neural network was trained, and the final accuracy was 92.93%, which is significantly better than the one that we got on the Spotify API dataset. Now, what would be interesting would be to use both of these models on the same songs and classify their genres. So that could be something that we can do in the future work. So the motivation for this research is a desire to investigate and comprehend the subtle patterns and differentiating characteristics that define diverse musical genres. Now let's conclude this project. So this is a summary of the results that we dove into. As you can see, association rule mining uncovered top co-occurrences of artists in user playlists from the last from data. And the decision tree showed that the randomized search CV tune model achieved the highest accuracy. The naive Bayes outperformed KNN and ended up struggling with the classical essentials playlists. Now let's conclude this project. So this comprehensive study systematically investigated the task of music genre classification and hit song prediction using various machine learning techniques on datasets derived from the Spotify API and other sources. The research aimed to develop effective models for accurately classifying songs into the respective genres and identifying potential hit songs based on audio features. In the context of genre classification, several supervised learning algorithms, including random forest, decision trees, naive Bayes, and neural networks, are rigorously evaluated. And the results demonstrated the effectiveness of random forest model, which achieved notable performance on both the Spotify API data and the GTZan benchmark dataset. And fine-tuning the random forest model through hyperparameter tuning marginally improved its accuracy further. Additionally, the neural network model exhibited robust performance on the GTZan dataset. The study also explored the application of ARM to uncover interesting co-occurrences and relationships between artists and genres within user playlists. This unsupervised approach provided valuable insights into user preferences and listening patterns. And in the domain of hit song prediction, the research investigated the performance of SVM with various kernels. While the models exhibited promising cross-validation scores, their accuracy on the test set remained modest. This outcome underscores the complexity of hit song prediction and suggests the need for more advanced feature engineering techniques and alternative modeling approaches to improve performance. Throughout the study, challenges were encountered, such as the difficulty in differentiating certain genres, particularly classical music, based solely on the available audio features. This highlights the potential for incorporating additional data sources for extracting more sophisticated features to enhance genre classification accuracy. Overall, this research contributes to the growing body of knowledge in the field of music information retrieval and demonstrates the potential of machine learning techniques for genre classification and music analytics. The findings lay the foundation for further exploration and refinement of these models, ultimately leading to improved user experience and more personalized recommendations. And the project can be accessed as there's a website, and all the code has been documented on this particular GitHub repository. And these are the references. Thank you.